do that. All right, so this is unit 2. This is measurements and calculations, okay? Measurement and calculations. This is going to be, some of it will be review, some of them will be very, very new. Yeah, no, ma'am, you can. Left light switch. Left light. Actually, you can probably turn both off if you want. They won't replace my bulb until the bulb actually goes out. And it's been like this for like 3 years. Every time I turn it on, it says replace the lamp, replace the lamp. And they won't, it needs to blow first. And maybe the new superintendent now that we might get to do that, but that was our policy before that. I've tried that. I've tried to leave it on for like I'll leave it on like a week at a time. Nothing will happen. Just keeps getting never. Right, so this is measurements and calculations unit 2. First thing we're going to talk about are measurements. I'm not really sure where I'm going with this. Measurement, there's 2 ways we're going to describe a measurement, okay? Measurement is going to be quantitative or qualitative, okay? That's the big thing to take out of this one. Qualitative or quantitative. A quantitative is information that contains numbers. Lily, you made 100% on your test. That is a quantitative measurement. Okay? Is there a number in that? Does it have an amount, size, or magnitude? Yes. Okay? If I told Drew, you did very well on your test. Is that quantitative or qualitative? Qualitative. They're not giving anything. Okay. So, McGrace, you traveled south to come to school. Quantitative or qualitative? Wrong. Quantitative contains numbers, okay? But it has a magnitude. Magnitude is direction, okay? So that was kind of a trick question. That magnitude is direction. Is there really a number for south? Yeah, south is 180 degrees, okay? So whether I tell you you walked, Marnika, you walked forward would be what? Quantitative or qualitative? No, ma'am, it would be quantitative because a direction, a magnitude is a direction. Forward would be a direction, okay? A qualitative thing would say it's hot in here. That is qualitative. Is there any exact quantity of, exact number of what hot is? I like to think of like when we went back to our last unit, we talked about elucidating, okay? Qualitative is not elucidating, okay? Qualitative is not elucidating. It is not clear. Hot is not clear. I mean, I'm sweating and you're over there wearing a hoodie. So that would be qualitative. That is qualitative, okay? The biggest thing, most people, numbers do very well with it, but the direction is something that you don't ever think of, okay? The direction is a quantity. So if it's negative, if you have negative something, that is also quantitative because negative is a magnitude, okay? We're going to talk about the magnitude more like we'll talk about vectors in the next unit, okay? But just in here, most of the time, you won't have to worry about magnitude being quantitative. It is. But most of the time, you'll have a number with that, okay? Any questions about quantitative and qualitative? Units of measurement. This should be review, I would hope. I would hope this would be review. We do use the SI unit. It was developed in the SI system was developed in the 1960s, okay? Developed in the 1960s. It is a variation of the metric system, okay? It's a variation of the metric system. It's slightly different from the metric system, but there are a lot of similarities, and the differences are very, very minute. Okay. They have 7 base units: meter, kilogram, second, Kelvin, mole, ampere, and candela. Okay. We add prefixes. We'll convert these units next week. Okay. We'll convert these units next week. That's probably a day, and I teach converting a very different way than probably most teachers have. It's not wrong to do it the other teacher's way, but if you want to take chemistry and you want to do some other things, my way is the same way that you'll do it in that. The good thing about the SI system is many other units can come from those units. So a meter per second, a kilogram times a meter divided by second is the same thing as a Newton. Okay, so in the English system, what we use, we don't really have new or derived units. Don't all have things, but a SI system, we get a lot of units from using those 7 units, okay? Some of them have their own names like newtons. Some of them are just like momentum doesn't. Momentum does not, okay? It does not have anything in there. Most are not SI. Now, these are non-SI base units, okay? The liter is not a base unit. You don't see it up there, but the liter is for volume. Volume is not a base unit, but we get a liter. They come up with that based on length times width times height, okay? A deciliter, a decimeter times a decimeter equals a liter, okay? A centimeter times a centimeter times a centimeter equals a liter, a milliliter. Your grades are updated, okay? Except for that vocab. That's not in there. I told you that. Yes. I told you guys that. You set the curve. You two set the curve. You got 4 points added. All right. So we're going to talk about each of the 7 SI units. A meter is used to measure length. Symbol is M. It is defined as the length that light travels in a certain time period, okay? A kilogram is used to measure mass. Its symbol is kg. A kilogram actually changes every year. The mass of the kilogram changes. The kilogram changes every single year. And it's centripetal force, centripetal acceleration. However, and this is why we talk about this unit, significant figure-wise, it doesn't really matter because it's such a small change that it doesn't affect us, okay? It doesn't affect us. The kilogram, the meter is the metric unit. The gram is the metric unit. In SI system, we use the kilogram, okay? We use the kilogram. It's used to measure mass. How do we measure length in America, in the English system? Inches. How else? Feet. Not mile, not centimeters. Centimeters would also be the SI system. Kilogram, how do we measure mass? Now, how do we measure? What units do we use to measure mass in the English system? Pounds. Pounds. Well, weight and mass are 2 different things, and we'll talk about that. However, Americans as humans, we are lazy, and we say I weigh 212 pounds, when my mass really is 212 pounds. My weight is like over 1,000. Gravitational force exerted on an object, yes ma'am. A second measures time, symbols S, defined by the time for a certain number of periods of radiation for a certain cesium atom to occur. Now I have a question on there. Why is time not defined as length of the day? Anybody? Why is time not defined as the length of the day? I mean, we have a definition for it. Why do we not use the length of the day? Anybody? Every day is longer than the last. Earth is, our length, we define a day as how long it takes the Earth to make a complete revolution, correct? Every day, the Earth moves a little bit slower than it did the day before. Now, it's something like in a million years, you're going to add a second to a day. So it's nothing that's that big, but that's why they don't use it. But every day is moving a little bit slower. Who came up with that? I mean, we're talking about physics. You got 2 go-to answers for physics. Newton and Einstein are the 2 go-to answers. Einstein would have been the correct answer on that one, okay? Einstein would be the correct answer. Kelvin measures temperature, okay? Its symbol is a capital K. This is not degrees K. This is a very common mistake. How do we measure temperature in America, in the English system? Fahrenheit. How is it done in the metric system? Celsius, okay? Celsius can be negative. Fahrenheit can be negative. We'll convert all these things later on. couple things with Kelvin. 0 Kelvin is absolute zero. It's a theoretical number. At absolute zero, all motion stops. So my pen is being held together because there are particles in motion. Okay? Now you can't really see them moving, but they are, the atoms are moving. If it would get to 0 Kelvin, the pen would disintegrate because those atoms would no longer stay next to each other. They would stop moving. So in a way, you could say you're destroying mass when they stop moving. We've never been to 0 Kelvin. 4 Kelvin is the coolest we've ever gotten. And just as an FYI, 4 Kelvin is, I'll pull it up on Google so I'm not doing the math. What is 4 Kelvin is negative 452 degrees Fahrenheit. There's no such thing as cold. That's the first thing I have to say with it. It's actually very much below freezing. Yes, no, that would be freezing. There's a great absence of heat. So that is negative 452. The coldest we've ever recorded on Earth has been negative 72. Like an Earth spot. A place in Russia was negative 72 degrees Fahrenheit one time. Yeah, I mean, it was, yeah, there you go, absence of heat. Now, we've got down to 4 Kelvin, okay? But to get something that cold, you have to insulate it very, 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 very much so. We're going to talk later on this year about an NMR machine. Anybody ever had an MRI done? You pretty much lay in the machine? Okay. Like if you like tear a ligament or something, you could, like, you know, x-rays do bones, okay? MRIs do ligaments and muscles and things like that. You get it for your brain sometimes too. You get an MRI or a CAT scan. And the NMR is actually based on a chemistry thing. Pardon me, the MRI is based on a chemistry thing, NMR. And like SEMO has one. And it's in a little bitty closet in the basement, the NMR machine is. And it has, I don't remember the exact temperature it has to be, but there's a little spot where you stick your sample in, and then it's surrounded by liquid nitrogen. And then the room, they try to keep at 50 degrees Fahrenheit. If the temperature goes up to 55 degrees Fahrenheit, they have to fill up the liquid nitrogen like twice as often. So like you get in big trouble if you leave the door open in there because it costs a lot of money. So, and that's nowhere near 4 Kelvin. So to get something to 4 Kelvin, I mean, it would be like this pen, and the entire school would be in the dead center of the school. And the one room be cooler, the next room be cooler. Then, I mean, a little bit warmer. Had to be very much insulated. But that's 0 Kelvin, absolute zero. 273 is the freezing point of water. 373 is the boiling point. We'll talk about these a lot more. Those are just some important numbers on the Kelvin scale. The mole, well, we'll never talk about the mole in here, other than it being an SI unit. The mole is the measured amount of a substance. That is a chemistry topic, okay? That is a chemistry topic. A mole is defined as the amount of a substance that contains exactly the same number of particles as there are in exactly 12 grams of carbon-12. I.e., 1 mole, now a mole is different for each thing. A mole of carbon is like 1 charcoal briquette. Okay? 1 charcoal briquette. And there are this many atoms in 1 charcoal briquette. Because how do I know this? It's a big time chemistry thing. Just so you know, that's 1,000. That's 1,000,000. That's 1,000,000,000. Trillion. And I'm out. I don't know what comes next. I knew that one. So 60 sextillion in number of atoms in 1 piece of charcoal. Okay. Now the reason they do this is, you know, 1 mole of charcoal is that much. Okay, it has that many. You know, no piece of charcoal is about yay by yay. A piece of gold would be like a centimeter. 1 mole of gold would be about a centimeter, okay? It's kind of a way that they try to come up instead of using mass all the time. But that is a chemistry topic. Ampere measures electric current. Its symbol is A. Where have you seen amps? Sound. That's one place, yes. Watch the light bulbs. Anybody ever blown a fuse in your house? Or if you fuse somewhere? Those different fuses have different ampere ratings, okay? You know, there's something that's 5 amps, if it gets about 5 amps, it melts, okay? 10, 25, 30, and stuff like that. Females, who has ever killed the electricity in your bathroom? You haven't? You haven't, do you leave your curling iron on, your blow dryer on the same time? But have you had them on at the same time? Because if you do, there'll be too much electric current flowing through it, and you have to go flip your circuit breaker. Okay, go do that and see if your parents get mad at you. It won't burn your house down. It just turn off the light. Well, it should not at all, because it's made to trip first. Okay, a circuit breaker is, and that's measures electric current. We talk about that a lot. Candela, I will tell you this: I have never in my life discussed candelas or used a candela. It measures light intensity. That's where it comes from. I mean, it's, you know, I don't know the exact definition of it. I have never ever used candela. How do we measure light intensity in everyday life? You said it a while ago. One kind of way. It's not a true way. Watts. You know, a 60-watt light bulb can give off more light than a 45-watt light bulb, isn't it? Ever heard of lumens? That's how we typically measure. Not the company, not the lumens. That's a computer company. What? Yes. Yeah. I know at church, we bought some spotlights for our church, and I don't remember. It's like I bought like 1,000 lumen, and our priest didn't like it. He wanted even a higher one, so we went and found a 1,350 lumen. But I've never used candela. It's just SI unit CD. Okay, accuracy and precision are one of my favorite things to talk about. Accuracy and precision. Okay, accuracy is the closeness of a measurement to the accepted value. Okay, accuracy is the closeness of a measurement to an accepted value. I like to think of this, and precision is the closest of a group of measurements. I like to think of, I like to think of accuracy as who's played darts. How are you accurate in a dartboard? You hit the bullseye, okay? You know, I might have a dartboard and I throw 3 darts. I hit the bullseye once, I'm accurate, correct? Precision is how close you are to each other, okay? So accuracy, did you hit what you're supposed to hit, okay? Precision is, are they close to each other, okay? So maybe I didn't hit the bullseye every time, but I hit the 15-point every time. That's being precise, okay? That's being precise. Would you rather be accurate or precise? If you had to choose one. Precise. Who shot a gun before? Who goes deer hunting? Okay. Well, you know, I like to think like deer hunting is like, that's what people go sight in their rifles, okay? If you're precise, you can adjust it to make it accurate, can't you? You know, if you are, or even in a lab, if you're 1 milliliter off every time, you can adjust your results for that 1 milliliter, can't you? If you're 1 milliliter off 8 milliliters and 4 milliliters, are you precise? No, those are very big differences, okay? Those are very big differences. Are our scales accurate or precise? The electronic balances we use, are they accurate or precise? You're all correct. You're all correct, okay. How do you make them precise? You zero it out each time, don't you? You get 0 each time. And it's accurate because it should be 100 grams, should be 100 grams. Like I think of, we had two different scales out here. The one was a little bit better than the other one. I can buy a more precise scale, okay? But they're both pretty much precise. So accuracy is, did you hit the target? Precision, are they close to each other? Significant figures, this is my favorite thing to talk about. A significant figure is a measurement consists of all digits with known certainty plus one final digit, which is somewhat uncertain or an estimate. That's a lot of definition. It is not uncertain, I mean, it is uncertain, but it is not insignificant. It is very, very significant. We use significant figures to increase the amount of precision. Significant figures are used to increase the amount of precision. Conversion factors have an infinite number of significant figures. We'll talk about that next week, okay? Here's the big thing. Everything you do from here on out must have the correct number of significant figures. From here on out. This lab we just did, I didn't care if it had the correct number of significant figures, okay? Like you asked, and this is, y'all have kind of talked about this, but you haven't. Who asked me, well, how many decimals do I need in my answer? How many numbers do I need in my answer? Did anybody ask me that when you were doing your calculations? We all talked, we did, and that's a significant figure. We have rules for that now, okay? We have rules for that. We're going to have rules to determine how you round up. Yes, sir. So here come the rules. First rule, all non-zero numbers are significant. This is the easy rule. Okay, this is the easy rule. All non-zero numbers are significant. 987, how many non-zero numbers do you have? 987, how many non-zero numbers do you have? 3. So you have 3 significant figures, okay? 21, how many non-zero numbers do you have? 2. So there are 2 significant figures. 18.19. How many non-zero numbers do you have? So they're all 4 significant, okay? This is the easy rule. Example 2, rule number 2, zeros that are in between 2 non-zero numbers are always significant. So zeros in between 2 non-zeros are significant. This is called the sandwich rule, okay? So in my example, 908, I have 2 non-zero numbers, correct? So those are significant. So anything in between those 2 numbers would also be significant. We're going to go back and do a lot of more examples of this stuff, okay? That's the sandwich rule. Number 3. Number 2 is still pretty easy. Number 3. Zeros in front of non-zero numbers are non-significant. That's the placeholder rule. Zeros in front of non-zero numbers are significant, are insignificant, are never significant. So my example, I have 3 non-zero numbers in this, correct? So those 3 are significant, but my 2 zeros in front of it are those are placeholders, okay? Those are placeholders, so those are insignificant. So they are not significant. So you only have 3 significant digits. Why are you going to miss school? Why are you scheduling to miss school during my class period? You only go to school 2.5 days a week. I see. All right, next rule. And here's the kicker. This one's probably the hardest one. Zeros that end a number, as long as they are behind the decimal point, are significant. So these two zeros are after a decimal point, after a number. They are significant. After the decimal, after a number, are significant. You can, yes. But we're gonna have this is just term number of significant figures. We're gonna have rules here for a little bit of like different rules for adding, subtracting, or multiplying and dividing. Okay. Now here's the last rule. Zeros that end a number and are to the left of the decimal point may or may not be significant. I have a rule for when they are. So after the decimal, after number always are. And this is where this number 5 is going to trip you up if you look answers up on the internet. Because this number 5 is kind of, some people don't really know what they're talking about doing it. If I show a decimal point, those zeros are significant, okay? So in this one, these 5 0 are significant. The 0 at the end is significant because I'm telling you that it is with the decimal point, okay? So 560 would have 3. If there is no decimal point, it is not significant. So this 900, there's no decimal, only have one non-zero number. Let's get some examples going. Right. So let me change my screen here. Let me make sure I'm still sharing that screen. All right. So my first example, and we'll go in order. There's my number. How many significant figures you have? 3. That's our first rule, isn't it? That is, all non-zero numbers are significant. I need to zoom that in a little bit. That better? That better? Oh, yes, ma'am. That means you're coming that close. That means you're next. And if you want to pull the chair out, it's up to you. How many? 3. That's our rule that numbers in front are not significant. That's our placeholder. Numbers in front are not significant. What? 8. This 0 is not significant, is it? Because that is in front of it. This 0 is because of the because of the sandwich rule. So that would be 8. That would be correct. It's your turn. Feeling. That's clearly your favorite shirt. What? That's the only one I think I've seen. See, I don't even pay. I don't like Harry Potter. 5. Okay. This is the rule that all so these 3 are significant because they're non-zero numbers. Our rule here is zeros after a number. These zeros are after a number and after the decimal are significant. So it is 5. Two. Why is that 0 not significant? Because there's no decimal point. That's correct. Marnika? It is just 1. You're correct. There's all these zeros. There's not a number in front of it. Correct. That's the placeholder rule. Your turn, Lillian. No, ma'am, you do not. No, ma'am. No, ma'am. Anybody like to venture a hypothesis? No. No, ma'am. No. 3 is the correct answer. This doesn't matter. That times 10 to the 4th doesn't matter, okay? That's called, it's in scientific notation, okay? So our rules are still just all non-zero numbers are significant, okay? 2, non-zero number, and this 0 being after a decimal, after a number is significant. No, ma'am. Is this 0 significant? Yes. And it's after a number, after a decimal, okay? And the other zeros are sandwich rules. So the answer would have been 11 on that one. Last time through on this. This part is pretty easy. Yes. Okay. This is correct being 8 because is this 0? It's after a decimal, correct? Is it after a number? Yes. It's after 4, isn't it? Doesn't have to be a number, a non-zero number directly. I didn't say directly in front of it, as long as it's after it. And then so we made this significant. So then via sandwich rule, those ones right there are also significant. Right. No, ma'am. Those zeros are not significant. That's the rule number 5. They may or may not be significant. How would I force correct? How would I have made those numbers significant? Put a decimal point there. All right, we all kind of good with that? All right, let's continue on to some, not really something else, but continue on more with this. Make sure I'm sharing this. Right. So that's our significant figure rule. Rounding. This is mostly pretty easy. Except for one thing that every math teacher has taught you incorrectly in your entire life. So, greater than 5, we round up, correct? Less than 5, so like this one, 59.67, I'm asking for 3 significant figures. So my third significant figure is 6. Number after that, greater than 5, so I'd round up to 59.7. Less than 5, what we do? Keep it the same. So if I want this to 3 significant figures, 59.41, my third significant figure being 4, number after that is less than 5, so I keep it the same, so 59.4. We all good so far? If it's exactly 5, what do you do? What your math teacher told you to do? Round up. Everyone agree with that? That's wrong. Okay? All that does is that gives you bias. If I always round up, my number will be bigger than it should be at the end, shouldn't it? So what I do is I have a rule. Okay? So let me back this up. So it's 5. So now this one I want to go to 3 significant figures. Where's my mouse? Where's my mouse? Third significant figure being 3. Oh, third significant figure being 3. It's greater than 5 after it, correct? Because 5, 2 is greater than 5. So I would round up. If it's 5, if it's exactly 5, I round to the even number. I round to the even number. So 59.45. My third significant figure is 4. The number after that is exactly 5, correct? So my options, if I would round up, it would be 59.5. I keep it the same, be 59.4. Which one ends with the even number? 4. So it would be 59.4. 59.35 is exactly 5. So I would either round, if I'd round up, it'd be 59.4. If I'd keep it the same, it'd be 59.3. However, you round to the even number. Even number is 4. So I would round that one to 59.4 also. Does that make sense to you guys? Round to the even number. So that's the only thing that's kind of hard and different about this, okay? Is this exactly 5? Exactly 5, round to even. Exactly 5, round to even. Look at it when you lean forward, how much bigger it makes your head look. Resume my recording, my last slide. Back. ready to go. This is actually, we're going to stop here today, okay? So Monday, which back with you guys again, Monday we're going to talk about adding, subtracting, multiplying, and dividing. Today your homework is going to be just over rounding and picking out the correct number of significant figures, okay? It'll be a worksheet, bunch of things on it, and just, I don't need the explanations, just tell me how many it has, okay? Does that make sense to everyone?